Okay, so what I'd like to do in these examples is I'd like to show you how to use the interior angle sum of a polygon. We've already developed it and we came up with the fact that it's n, where n is the number of sides, take away 2 times 180 degrees. And we developed that by splitting the polygons into triangles and seeing how many triangles we could make out of one polygon. So the first example that I've got is looking at finding one interior angle of a regular 12-sided shape. It's the sort of question that you may well have worked through by considering exterior angles. And that's the first way that I'm going to do it. We need to remember it's regular. That means that it's got sides that are the same length and it's got equal angles. The important thing for this question is the fact that the angles are equal. So that accounts for both interior and exterior angles. So we know that the sum of the exterior angles is 360 degrees. So one exterior angle is going to be 360 degrees shared amongst all of those 12 exterior angles, which is 30 degrees. That then allows me to say that one interior angle, because we know that interior angles and exterior angles add up to make a straight line, to make 180 degrees. One interior angle is therefore 180 degrees, take away 30 degrees, which is 150 degrees. If, on the other hand, I wanted to use the interior angle sum, I need to say that n is 12. My interior angle sum is 12 take away 2 times 180. So that's going to be, n take away 2. I then replace the n with the 12. 12 take away 2 times 180, which is 10 times 180, which is 1,800. Please don't just randomly write 1,800 down without actually explaining what it is that you're calculating. So we can then say, therefore, one interior angle is that 1,800 shared amongst the 12 interior angles, because they are also equal because it's a regular polygon. And that gives me that 150 degrees. And actually it's very important that for the first one, if you are using the first method, you do need to use the words to explain when it's the exterior and when it's the interior angle that you are considering. Now, if we move on to the next mini whiteboard, we've got two examples on that mini whiteboard. First one, how many sides does a polygon have if its interior angles add up to 2,700 degrees? What we don't know for that one is we don't know n. How many sides does it have? We don't know. So what we've got is we know the interior angle sum is 2,700. We also know that the interior angle sum is n take away 2 times 180. Now I can combine both of those to set up an equation, and I can solve that to find out what n is. So if I put both of those together, because they both give me the interior angle sum, what I've got is I've got n take away 2 times 180 is equal to 2,700. Now I'm going to start by dividing by 180 first, so that I get the n take away 2 on its own. And that's going to give me n take away 2 equals 15. I want to get n on its own, so I'm going to add 2 to both sides, and that's going to give me n equals 17. So I know that it has 17 sides. Finish it off by saying what you found out. It has 17 sides. The next one is slightly different, and you might be looking at that polygon and thinking, well, that's an odd polygon. Any polygon that has one of its vertices, one of its corners pushed in, is called a concave polygon. The same rules apply for it, so the interior angle sum can be worked out in exactly the same way. It's just got an extra name. In all honesty, the polygons you're used to are really called convex polygons, but we don't tend to call them convex. So we need to start off by finding out what is n. That's the most important thing. You can either count the number of sides or you can count the number of angles. If we just make a little mark to remind ourselves we're starting at that angle, I've got 1, 2, 3, 4, 5, 6, so n is 6. That tells me then that the interior angle sum is going to be 6 take away 2 times 180, which is 4 times 180, which is 720 degrees. Therefore, to find x, all I need to do is subtract the other angles from it. But I'm going to try and write it out nicely and as a mathematical sentence. So we've got that x is going to be 720 take away 85 degrees plus 95 degrees plus 105 degrees plus 85 degrees plus 75 degrees. Excuse me while I get my calculator. We'll add up those ones that are in that bracket. That gives me 445, so I've got 720 take away 445. Which gives me 275 degrees, which is actually realistically what I would probably expect because it's clearly a reflex angle. Okay, although you cannot assume that any diagram is drawn to scale. Be careful about how you set your work out. Okay, make sure that things are labelled and that it is clear what it is you are doing.